Okay, for today, we are graphing trig. So I just taught you what secant and cosecant and those kind of things look like. All right. So remember that secant rides on the back of its sister. And so they're kind of like loops. They look a little bit like parabolas. All right. So let's just see if you remember. I'll give you one softball, super easy one. 2 secant of x. Hint, start by graphing its sister. And then at the end, make sure you remove the sister so that all you have on your graph is secant. Make sure it's got labels on all the key spots, There's 4 spots that start, I like to start at the end with 2 pi because this is based on its sister function, which has a period of 2 pi. All right, so start with that one, and then once you finish that one, that should be really easy for you. Try this one. 3 sine of 4 pi minus pi over 2. No. I think that's a little more carefully. There, I'm just going to make it minus 1. And note, there are not parentheses around this. So there are not parentheses. I'll even leave the leftover parentheses over there to show you what that -1 is. Because if that -1 was on the inside, it'd be a shift to the right. This is not a -1 on the inside. All right, two completely separate questions. For those that just arrived back from the bathroom, that spot, the one above it there, that's just graph 2 secant of x by starting with the sister function. And then remember that secant rides on the back of its sister function. And then this blue one, which does not have parentheses around the 4 pi minus 1. That would be a more R3 level. The black one would be like an R2 level. All right, I'm going to pause for a second while you try these 2 oldies but goodies. Okay, let's see how you did to start with. Just the first one. Secant rides on the back of sine. True or false? False. Very good. It rides in the back of what? Cosine. So cosine is the one that starts at 1. And then I have to always do this in 4 parts. You might be better at making waves than me, but all right, now that's 1. The lowest it goes is -1. That's also known as the range. Okay. Then I should label these 4 spots. I labeled the first one. This one's pi, this one's pi over 2, and this one's 3 pi over 2. That is how you start. Next, I realize, wait a minute, I'm actually supposed to be graphing secant. So secant is the one that's 1 over sine. That means when sine hits 0, which would be here and here, it can't exist. So that reminds me that I need to stay in between these and make my loops. Now this would have a whole loop like this and a whole loop like that. And there's nothing wrong with what I just did. It's just I graphed more than 1 period of secant. Do you get what I'm saying? Because I got 2 upper loops and 1 lower loop. If I just make 1 more lower loop, I would have 2 full periods of secant. So if you want to keep it to just 1 period of it, I could cut off some of this and cut off some of that, and that'll keep it at 1 period. 2 half of the upper loops and 1 lower loop. All right, then, since this was a 1, now it's going to be a 2, and this is a -2. That's the only stretch or transformation I did of this function. So I can just relabel right here, and I'm good to go. Now, if I left it this way, I probably wouldn't have marked it fully wrong, but I'd have to take off partial credit. And on a Marzano-style test, the only way we do that is by taking off 5% of your total grade of the test for leaving that in there. Because that's not part of secant. Secant is just the red part there. Raise your hand if you would have had that one right. Okay, good. Awesome. Questions? Yes? It actually wouldn't matter in this case, but if you want a general rule, we have to do these in the right order, right? You make it secant first because you're not actually doing cosine. You make it secant first. Then you do the transformations to it. All right. What if there had been like a, let me think, 2 in here on the inside? All you had to do then would be to take these numbers down here and multiply them all by 2? No, multiply them all by what? 1/2, because you don't trust the stuff up there on the inside. It does the opposite of what you would think. So we multiply everything by 1/2. 1/2, 1/2, 1/2. Now that wasn't part of your problem. I'm just saying if it had been, all you had to do is renumber it. No big deal. Okay. All right. Now looking at this more complicated one down here. 3 sine of 4 pi minus 1. I hope that you have started by graphing sine. 4 important spots. Label them all. Your labels are the main thing that I grade on this test is the labels. Because everybody can draw a wave, okay? So the waves aren't messed up. It's always the numbering that's messed up. So be extra careful on how you label your x and your y axis. And this is 1 and this is -1. Okay, there we go. There's sine. Now everybody can handle this part. The 3 in front, that just changes this to a 3 and this to a -3. Don't be too proud of yourself if you can do that. But how about that 4? Well, that's not that bad either. You just multiply everything by 4, right? No, multiply everything by 1/4. And you can't leave it like that. That would be leaving me a math problem. I get to see the answers. You get to do the math problem. Pi over 8, pi over 4. And if you want to start counting by something, count it by this first one, because it goes from 0 to there, right? So this would be 1 pi over 8. That's 2 pi over 8. This next one must be 3 pi over 8. And the next one must be 4 pi over 8. But you normally would write that as what? Pi over 2. You get how 4 pi over 8 reduces to pi over 2. Okay. And now, here's a tough question for you. What is the period of this function? It's actually not a tough question. Period used to be 2 pi until we stretched it, or shrunk it, actually, because it seems like it's a stretch, it's actually a shrink. So the period used to be 2 pi. So whatever used to be here, this answer, that's the period of this function. The period of this function, it gets a complete cycle done by pi over 2. Yes? Meters. I would want you to simplify. I would know what you meant if you said 4 pi over 8. And depending on how many you hadn't simplified, I might have been able, if everything else was right, I might have been able to overlook that because it's pretty small, but why not do it right if you think of it? All right, next thing. I had to move the whole thing -1, and then I'll be done with this problem. What the heck does -1 mean if it's on the outside like that? Down. Down how far? 1. How far is 1? Ooh, that's an important question. 1 mark on the line? No, my marks are at 3 now. See what I'm saying? So if you grabbed your blue line here and moved it all the way down, you'd be moving it down 3. So you need to move it down 1. I would look for people that had moved it down that far and say, nope, you moved it down 3. Should only be down that far. Yes? If you had labeled this at -1 and this at 2, then it would have been okay. All right. You can't just have one label, but if you had the top and the bottom labeled, then I'd have been okay. Yes?
Yeah, so if we go like the top, the amplitude for the top would be like 2.
Oh, no. Pay attention now. There's no amplitude for the top and amplitude for the bottom.
Like,
I don't know what you mean. I want to find out what you mean.
the top would go to the bottom of that.
There you go. Okay, now the amplitude is what, by the way?
3.
It's 3, because it goes from -1 to 2, and from -1 down to actually the lower limit down here would be at -4. So the amplitude stays at 3. There's no such thing as a negative amplitude, by the way. There can be a negative number there, but that's the amplitude is a positive thing. It's going up or down by some amount, and that's a positive number. All right, so there's a review up till now. You have learned to graph secant and cosecant and cotangent even. Ooh, those are so different. We should probably do a practice of tangent because it's so different. All right, so let's try a tangent one. And then cotangent is just a little different, but one thing at a time. Let's graph a tangent. Y equals 3 tan of 2 theta. Hint, start by graphing normal tangent. And if you don't remember what it looks like, make a note to yourself. You must memorize tangent function. It's got asymptotes. It's kind of a wave. If you don't remember it, I'll show you in about a minute, but I want you to try to remember what it sort of looks like. It's not a wave that goes forever from left to right because it's got asymptotes. Okay, I'm hoping that you remembered the parent was like this. If nothing else, you had time to go look in your notes and you should have been able to find it. So that's tangent. Just plain old tangent. And you'd need to know some labels. There's not many because there's only 2 asymptotes here. But that's at pi over 2, and this is at negative pi over 2. Okay. So, how many of you knew that that was kind of what it looked like? You had the parent one memorized. Good. Now, let's move on from there. Right now, I want to just get a quick look at what you think the final answer looked like. I'm going to pause for a second. So, you should now take this and do some stuff to it. You need a good, nice example like this. This is a typical test question. You have to know tangent, you have to know sine and cosine. All right, so what does this 3 mean? I hope you know that that's going to take what used to be 1, which, by the way, also happens to coincide with being halfway across here. That's where 1 would be. And here, halfway across here, if you follow it down, touches like down here, this would be 1 and negative 1. I'm off a little bit because I didn't do it perfectly. But your 1 and your negative 1 now need to be changed because this 3 tells me to stretch it and make it a 3 and a negative 3. Raise your hand if you had done that already. Awesome. And then last, we just got to do a little renumbering along here. I only need where the asymptotes are. That's critical. Okay, so this asymptote here is at pi over 2. So I multiply it by 2? No. I'll multiply by 1/2. So if I had asked where are the asymptotes, you would say at pi over 4 and negative pi over 4. And I'm always amazed at how many kids can't tell me then where any other asymptotes are. Because do you get tangent? Doesn't just exist here. There's one to the right of it. You know what I mean? There's another one over here. I saw some of your graphs had that. That's awesome. It goes on forever, right? So my next question is, where would the next asymptote be? And just be careful. It's a common mistake, and I'm not saying you did this, but it's a common mistake to go, oh, so we went over pi over 4, so I should just go over pi over 4 again. No, you don't. You have to go over far enough, and I think you said it right, actually, but you have to go over far enough so that you have how far? That far between the asymptotes, right? All right, so I'm going to pause for a second while you follow. I asked that follow-up question. Where would the next asymptote be? All right, so where would the next asymptote be? It would be, well, how far between asymptotes? Normally, there's 1 pi between asymptotes because this thing has a period of pi. That's important to know. But we changed it by doing this. Do we make it wider or narrower? Narrower. So our period is the distance between the asymptotes is less than pi now. Well, we can even just do it this way. It goes from pi over 4 to negative pi over 4, and so that's 1 pi over 4 plus this would be 2 pi over 4, also known as pi over 2. I'm going to keep it as 2 pi over 4, though, because then when I add to this 2 pi over 4 in that direction, that makes it at 1 pi over 4 plus the 2 pi over 4 distance between the asymptotes. So the next asymptote would have to be at what? 3 pi over 4. Again, you can't just add this distance. Between asymptotes, it's the whole distance here. All right. Okay, that's enough about tangent. So now, we have done almost everything that you need to know for this next test, which is cool, because we have a lab to throw in here, too. It's called the TIDES lab. But that'll be good. It'll give you a chance to practice this stuff. And there's stuff like the TIDE lab on the test. So, anyway, let's just talk about tides for a moment. Do you get that there's a wave? It's not really when you have a tide coming in and out, you don't have a wave, but you have a high tide and you have a low tide, right? Now, we aren't ocean people here in Minnesota, but if we were out on a coast, there are some places where the tide is massive. Like there are some places in Alaska, for example, where when the tide comes in, it flows in so fast that you actually like see a wave coming in. And people sometimes that aren't used to such a violent change in tides where they might be from a place like in Florida where the tide only goes up or down like 3-4 feet. Some places will be like a 15 or 20 foot difference between low tide and high tide. And all that water having to move makes it a pretty violent thing when it starts to change tides. So people sometimes walk out when it's low tide. They walk out to where the edge of the water is. Why is that bad? Well, because it's really soft and muddy and really hard to walk in. And then what if the tide starts coming in? Now you got to run through the mud as the tide's coming behind you. And there's people who've died from that. So anyway, the low and the high tide difference, think about that as this. Isn't that kind of like the amplitude? Okay. And what if the low tide is where we're measuring it at 14 feet on a pole? This is like on a dock pole. And then the high tide is at like 18 feet on that pole. Again, this is like a big wooden pole. I'll make it black. And this is where the water level is at low tide. Here's where the water level is at high tide on this dock pole. Okay. And this is at 14 feet, and this is at 18 feet. Do you get that the line that runs right down the middle of that is important? Think about it. That's the line where the sine wave is going to go up and down on. What is that spot exactly between 14 and 18? That's where 16 would be. Okay. Then, what's the amplitude of our wave? This isn't me just talking about a real-world application. You have to do this on the test, so pay attention. So the low spot and the high spot would be important. What's in the middle of that's important, because then we can tell the amplitude is from the middle all the way to the highest, or you could say from the middle to the lowest. Either way, what's the amplitude in this case? 2. And now I can construct my sinusoidal. Do you think a plain old-fashioned sine wave, just sine of theta, matches this data exactly? Of course not. I want you to think about how sine wave would have started here at 0 and it'd be going up and down like that. Okay, that is not a great sine wave. I want to try to make that a little more consistent. There we go. Okay, but this sine wave has this little line running down the middle. We'll call it the center line. The center line of it needs to move up. How far up should it move to replicate our tide coming in and out? 16. It needs to go up 16. So how am I going to make my sine function move up 16? Huh? You get what I'm doing here? Okay. Up 16. Next, what goes in the front? The amplitude, which is what? 2. Awesome. Now, the only thing left is this part, which I haven't talked about because it has to do with how much time it took to go from a high tide to a low tide and then back up to a high tide. Do you get that I'd need to know the time it takes to get from here to here? Because the time is the x-axis. This is like what the time that gets measured. And aren't those numbers always important? Yeah. What is normal for normal sine? 2 pi. Don't forget, that just means 2 times 3.14. Okay? Pi isn't some special thing. I mean, it is special, of course, but it's just a number. So that means 2 times 3.14 means about 6.28. That's 6.28 on a normal sine curve. Well, how far is what is our time that goes from here to here? Well, let's say I said from high tide to low tide was, well, you guys know how many tides there are in a typical day. You probably have no idea. All right. 2. Okay. So that means about 12 hours apart. Okay. So, very good. If this is from high tide to low tide, and this was a time of 12 hours, then how long does it take to complete one cycle? And just to clarify, from high to low, that's not a cycle. That's the down phase of the cycle. If from here to here, from here, the high to the low is 12 hours, then remember when it's done with its cycle, it's actually going to be all the way back up again. So how long would that be? 24 hours. So you figure out how far it is from high to low, and then you double it. Because from high to low, that is half of a cycle. All right. So we need a new problem because that one's getting messy. All right. Actually, I should probably finish it though. Now, the easiest function to use on this, believe it or not, isn't sine. It's cosine. But why? Because if I start with my x and y axis looking like, I'm going to use big red lines for them. Oh, I got off a smidge just at the end there. There we go. It's really easy to shift the highest part of the wave. And do you get that my blue one looks more like cosine right now than it does like sine? Because that starts at the highest part of the wave. Do you get that the highest part of the wave is easy to see? That's why we're going to use cosine instead of sine, because for sine, where it starts at 0, 0 is actually right in the middle of a low spot and a high spot. If you don't understand that, it's okay, just trust me. The cosine is way easier to use because cosine, you can center the peak of the wave right on your x and y axis. Know what I mean? That's how cosine looks. And then you can just figure out how far it's been shifted over if it's not exactly there. So if my cosine is actually over here, I can see how far the shift was by just looking at the x-coordinate of the peak of the wave, because that'll tell me how far over it's been moved. All right, so just remember this. We're always going to use cosine for these functions instead of sine, even though sine is the classic wave, and these are even called sinusoidals. Cosine works so much easier. All right, the last thing we got to do is figure out what we put in here. Well, what's the normal period for sine? It's 2 pi normally, okay? But for us, we're going to do this in terms of hours, because to model tides or to model any real-world data, we have to do it in terms of hours or minutes or whatever. Okay, so this is a good time to bring up a formula for finding B. I'm going to pause for a second. All right. The period of any sine or cosine function, or their sisters, is 2 pi over b. Add this to the list of a bajillion things that you've had to memorize in trig. You got to remember this one. The period is 2 pi over b. So what if I tell you b? Then you can tell the period really easy. If b is 4, then the period's 2 pi over 4. What if I tell you the period is actually 24 hours? Then I could put a 24 right here and solve for b. Do you get what I'm saying? So you can find your b term with this handy-dandy little formula. So is our period 24 hours? Yeah, it is, because from the high to the low is 12 hours. So we double that, makes our complete cycle from high tide to actually back to high tide again with 24 hours. So our period was 24. So I'm going to rearrange this thing. I multiply both sides by b, and I get 24b equals 2 pi. And then I'm going to divide both sides by 24, and I get b equals 2 pi over 24, which does reduce to pi over 12. That's my b term. That goes right here. Yes? I will gladly reiterate those for you in just a second. So this is pi over 12, and that's the b term. I'm going to take a second and do what he asked, which is a reminder of what are all the ABC stuff again. A is the number in front, and that's the amplitude. B is the stretch factor, but we just got a little formula for it. See if you have any short-term memory. What equals what over what? The period equals what again? 2 pi over b. So what is b? Well, you could rearrange this thing and say b is 2 pi over the period. What if the period is 2 pi? Well, then b must be 2 pi over 2 pi, which would be 1, which makes sense, I hope. All right. See, this is the shift. And if our wave was like this, do you get that this is how far cosine has been shifted? Because cosine normally starts like this, right? I should move this down, sorry. But if this is moved over, however far that's moved over, that's how far the shift was. And that's a horizontal shift, and this is a vertical shift. Remember how the tides weren't going from 0 up to 3 feet positive and then down to 3 feet negative? The tides were a height on a pole, and it was like the lowest. So basically, this whole wave was shifted way up. So this D, that's the vertical shift. And in our example, we had figured out that that center line, which is the thing that we want to think about as the thing that's shifting, the center line here, that center line moved up to 16 feet. That was the midline of our tide going back and forth. All right. I know this is kind of cruel for a Monday. All this thinking involved on a Monday. But this is our last thing. And we get to review for a few days, throw in a lab. Test is either, I think it's Thursday, but I'm going to talk with my colleagues to see if they're going to get it in. If they're all doing it Wednesday, I might move it up to Wednesday. We can do that. We just have to shift the lab back a little bit then. Okay, so how do you do a typical problem for today? For a typical problem for today, let's say we had, that height on a pole thing is a really common one. So let's say it's a new tide situation where the height on the pole at the high tide, it's 10 feet. At the low tide, it's 6 feet. You could tell that, right? Couldn't you like look on the pole and like wait till it's low tide and then you measure it and say, okay, that's at 14 feet. There's actually poles in the ocean that are numbered with like the depth of the water, you know, so that people can do this kind of thing. All right, so do you get that the midline that runs right down the middle is really important? You should already have that number. Next, you'll need to know, Mr. Server, how far or how long did it take to get from high tide to low tide? And what if I told you it actually took 10 hours? It's one of those things. The Earth is a weird place. It's not all consistent. You would think all the tides rise and fall the same amount. They don't. You would think they all happen at the same amount of time, and they don't. Okay, but let's say it's 10 hours between from low to high tide. It was 10 hours. Just to clarify, does that make 10 hours the period? No, from high to low does not make a full period. You got to get back up to high tide again. Yes, you can assume we'll take the same amount of time as it took to get from low to high tide. And actually, I should have said high to low tide, just because we want to use the cosine function. We're always focused on the high spot. The high to low was 10 hours. Would you write what you think the cosine function should be for this guy? You should know how far up it's shifted. You got a little formula that tells you the b. If you wrote it down, you can go back and look at your notes. There's a formula that we've got to find the b term. I'm going to pause while you give this one a try. Again, I'm going to show you a typical answer. This is not the right answer. Don't need a parenthesis at the end there. And we're not going to make this one be shifted because that's too much for your first problem like this. We'll just say that the high tide started right here at 0. You know what I mean? Like at high noon or whatever you're making this time. Because if it was shifted over a little bit, then we'd have to put that in there. We're not going to have a shift on this one. You should be able to write the sinusoidal like this, which is going to use cosine. I'll pause again. Okay, in the interest of time, I'm going to get back to it. I hope you figured out that that dotted line down the riddle was at 8, and that was a big deal because it told us a couple things. It told us that it's been shifted up 8, this dotted line that runs down the middle of cosine, which normally is down here, right, has to be shifted up 8. Next, that tells us this number, 8 up 8. Raise your hand if you had an up plus 8 at the end of your cosine function. That was a good thing. Okay, next, the distance between here and here is called the amplitude. How far is that? 2. Did you have a 2 at the beginning? Raise your hand if you had a 2 at the beginning. Good sign. Okay, next, what's that little formula that tells me this number in the front? Period is 2 pi over b. Did you know the period or did you know the b? From our data, we could tell the what? The period. We knew the period was, well, it wasn't 10 hours. Remember, that was from high to low tide. The total period then must have been what? 20 hours. So the period was 20. Can you tell what b would be then? Switch these two places, and you got b equals 2 pi over 20. Could that reduce? Yeah. Pi over 10. Raise your hand if you had that. Awesome. Then you got pretty much everything. And one more thing, we need a theta in there. Because remember, cosine of with no variable, then you don't have an equation. We need a theta. We need a pi over 10, or I would have been okay with 2 pi over 20. Just always reduce if you can. Now, what if this thing had been also shifted and they said that if this is, you know, exactly 0 o'clock, is there such a thing? Yes, in military time, there's 0 o'clock. Know when it is? It's the same as at 2,400 hours, so to speak. It's at the very beginning. It's like not noon, it's like 12:01 a.m. Okay? Yes? I didn't draw a secant. There's no graph here anyway at all. But this is just a pole. This is my pole that the okay. All right, I got you. No secant graph. All right, so there's and then if this had been shifted over a little bit, the peak was here when it should have been here, then we would say if this had been 2 hours, then it was shifted 2 hours and we would have put a -2 there. That's the final piece. Heavy duty stuff. But you're in an honors class. And this is the toughest part. Remember, test isn't until Thursday, I think. Maybe Wednesday, but you still would have, I'm pretty sure it's Thursday. At a minimum, you got at least another day of review in here, and I think 2. All right, so how do we take a chart that's got high and low tides on it and actually get these numbers from it? Do you get, if I have a chart that means that I have times and I have heights? Let's say this is at 0 a.m., the water was at 4 feet, and at 1 a.m. it was at 5 feet, and at 2 a.m. it was at 6 feet, and at 3 a.m. it went back down to 5 feet. Do you see what happened there? When did it reach its peak? At 2 a.m., it had a peak of 6, and now it's starting to go back down again. Do you think that peak is kind of important? Yeah. At 2 a.m., it was 6. I'm going to just keep this really simple. Let's say at 4 a.m., it's back down to 4. At 5 a.m., it starts to rise again, back up to 5. At 6 a.m., it's back up to 6. Do you get, this is what our data is going to basically do. It's going up to 6, back down to 4, back up to 6. So do you see how they're telling us our low and our high tide on the chart? All right. So then I could make a new thing, and if you wanted to, make it like a pole and say, here's my high tides at 6. My low tide was at 4 feet. Then right away, please always find the center line, which is at what in this case? 5. And then that tells you the amplitude was how much? 1. And we've even got the times. So we know how long did it take to get from low tide to high tide? From 0 to 2. It took 2 hours. I don't think there's any place on the planet that gets its low tide to high tide in 2 hours, but on my chart it just did. And then how long did it get back to low tide? A total of 4 hours to get from 4 back to 4. That's a complete cycle in 4 hours. That's also known as the period. The period in this case was 4 hours. To get from low tide to low tide or from high tide to high tide, that's a period. And what's that formula I just taught you? Period is 2 pi over b. Very good. And so if I know the period is 4 hours, put that in here and I could solve for b, and b would equal 2 pi over 4. I found my b term. What's this thing? It's the shift at the end. It's the vertical shift. So my equation for this would have been cosine of the b term I just figured out was 2 pi over 4 theta. And then the whole thing has a center line of 5. That means the whole thing has been shifted up 5 plus 5. And what was the amplitude of this guy? Amplitude was 1, so I could just put a 1 right there, and I've got it done. So when you get your chart of data, do you get what matters is your high tide and your low tide spots? You can kind of ignore all the other stuff. All you really cared about was, here's low tide, here's high tide. How long did it take to get from low to high? And that was 2 hours. And then why did I double it again? Because you got to get all the way back up, or back to where you were to get a full period. All right, that's a lot to absorb. Let's look at your homework. I'm going to pause for a second while I find that. Here's an example of a chart, for instance. This one was meant to be done in class. I'll give you one that you actually is assigned from homework so that you'll be able to check this with your answer key. All right, here we go. This first one, it gives you an equation, and we don't usually do that, so I'm going to skip that first one. We're going to go to this one. I want you to do problems 2 and 3 and 4. Those 3 questions, 2, 3, and 4. Now, let's start together here, because once you started, you're halfway done. Let's see if we can identify what's the highest, even though it's not about tides, what's the highest tide, so to speak, that you see on the whole chart? 23.9. Then that moment, even though I know if you're smart, you'll know that there's a chance that the data's off and that's not the highest spot, we're going to use that that's the highest spot. We're going to assume we caught it at its very peak. And then what's the lowest number you see on the chart? I see 14.1 here and here. Think about it. It's a wave, so it makes sense. It's going to go back and forth. So from this spot to this spot, for instance, there's a low tide to a high tide, so to speak. It's just temperatures. It's not tides. So how long did it take? How many hours did it take to go from 6 to 18? 12 hours. Is the period 12? It's not. What's the period? 24 hours. That center line, it goes between 14.1 and 23.9. You can even think of it as the post again, and this is going from the low of 14.1 to the high of 23.9. The dotted line that runs right down the middle of that. In case you haven't figured this out yet, you average the 2 numbers to find that. I always made them super simple, so it was obvious, but if they're icky numbers like that, average them. That'll be the center line that runs down the middle. Next, always use cosine. Cosine, the B term, you'll need that little B formula. Period equals what again? What's that formula? Period is 2 pi over B. Good. That'll tell you the B term. The A term is the amplitude. That's this distance from the low to the high. And this one is shifted. I want you to think about that. At time 0, we were not at our peak. It was shifted to the right how many hours? So that 6 has to be in your equation, and it'll be in here on the shift. It'll be to the right. We always do it to the right. How far? 6. I'll give you that part. Put that in. That's part of your answer. All right. We'll practice this more tomorrow. You got to do your part. And I haven't graded in a while. I am grading. Guaranteed. Promise. Problems 2, 3, and 4. So if you have to do nothing else, check the answer keys.